Welcome folks. Today I was going to be talking a little bit and showing you how to use an ohm meter and to check this high energy ignition coil. It's a separate coil, it's not your usual General Motors in the cap model. This is for a up to a mid-90s either an Astro or Safari minivan with a 4.3 liter V6 engine in it. And I'll also mention it has central port fuel injection as well. Kind of like a Spider deal. Only instead of 8 legs it's got 6 for the 6 poppet nozzles that enter the intake side of the cylinders there. Okay, so what I'll do is I'll show this, lift it up a little closer to show you the actual connections and stuff. You might not be able to see. I did highlight the area down here. There's 4 little tiny terminals in here that we have to excuse me, probe with the ohm meter test leads. And there's the high voltage output side of this coil. So I'll just lift it up here and hopefully I won't shake too bad here. But basically that's what you're looking at for testing. There's 4 little cavities in here. There's actually a wiring harness, if you will, that plugs into there when it's on the vehicle. Like I say, this coil it's got its own lead, high tension lead that goes to the center of the distributor cap. And this one actually, you have to fight it to remove it and put the new one on. And you can see here where I've actually filed or ground rivets that were securing it. It's over by the valve cover there on the right hand side in front of the passenger seat of the vehicle. Okay, on the right side there. But I'll just slowly rotate it to show you the different angles, the views that you'll get from the different angles. There's a straight on, and then I'll just slowly rotate it around here. There's laminations of steel here, thin steel, 20-30 thousandths thick. Like most electrical components, motors or whatever, they're always laminated steel, not one solid chunk. So I'll slowly rotate it, maybe a little quicker. That's what it looks like from the side. And I'll rotate it this way just to show you what's going on there. Like I say, there's 4 probably rivets and or screws, especially if we replace it. I think they supply it with screws if I remember rightly. So that's basically it. Hopefully my fingers aren't in the way too much, but that's what it looks like when I rotate the thing all over the place for you. Okay, back to the business end of this thing. Everything is on one end here. There's, like I say, 4 different cavity terminals. You have to probe the right ones or you're going to get readings that are a bit different and could mislead you a little bit. It'll still show okay. So I'll put this down, and what I'm going to do is put it on an angle here beside the multimeter that we'll just be using the ohm range on. I have other videos as well that show the different types of coils on my channel. Feel free to go and have a look at those as well if you like. Okay, let's see if we can square this up a little bit. Okay. There we go. Okay, so now what I'll show you before I get too far along is everything seems to require a little bit of a different approach to getting at things, to measure them and whatnot. The high output or the secondary side of this coil is easy to do. You just put the alligator clip. I don't know if you remember these from the other video if you saw it, but they're get their name alligator clip because they got alligator jaws there. Okay, obviously that'll work for the this terminal here. It's about almost 1/4 inch in diameter. No problem. I'll be able to get it to grab that. But these little ones here, now I don't know if you've seen the other videos, but these on both the black and the red test leads, these alligator clip, insulated alligator clip things just unscrew. Then you're left with a nail-like probe there. Okay, see if I can center that up a little bit, get the lighting to shine. Okay, so now what I found is when I went to stick this probe in, it's almost 1/16 of an inch in diameter. It just won't go into these small little cavities here where the metal contacts are hiding inside. Okay, so what we have here is something that's been around for years. I've actually got a couple of them that I'm going to be using in the alligator clips. So I'll just hold it in my hand here, but it's let's see which was the best way to hold this thing. It's called a T-pin. Use them for modeling or even dressmaking or whatever you like. It helps hold patterns and stuff, and because of this big T thing, it's almost 1/2 inch long. They're very easy to handle by hand, as opposed to just a little pin head that you get like you know, with little straight pins or even a small sewing needle or whatever, harder to grab. They'll still work the same, but this gives me a good area to grab onto to move it around. Like I say, you can temporarily hold patterns or for modeling or whatever if you're into balsa wood or whatever. They work great for that. So I've got a couple of these here, and what I'm going to do now, I guess I have to put my alligator clip back onto the red test probe here in order to use these things and grab on. Okay, so we'll start with the black one. Okay, we're going to test the low ohms reading on this coil. There's two readings we have to take, a low ohms and a high ohms. Basically the low one is for the primary coil. There's two coils inside this epoxy filled ignition coil. So I'm going to put the T-pin right in the alligator clip, that T part, so that the pin sticks down like so. Okay, I'm going to do the same thing with the red test lead with that alligator clip. Too much coffee again. And grind them in there, make sure they make a good connection. I did shine these up, they were a bit dull. I shined them up with some sandpaper to make sure that there wasn't going to be any problems with the connection. Okay, now to test, I'll just put this up right here to show you. I'll do it even here. For the low reading, where my fingers are pointing, you go diagonally. Okay, for the low measurement, where my index fingers are pointing, try to get the other ones out of the way there. Those two cavities, kitty corner to one another, those are the ones we take the low reading. And then for the high reading, we take this cavity here at the where my index finger is pointing, the top one, and the secondary stud here, the high tension lead that leads to your distributor cap goes on. So I'm going to put it down on the bench here, and I've got it zoomed in about right here so I could include the meter in this, and the numbers show up really large on the meter reading once we get her going here. Okay, so those test probes with ohms, you generally don't have to put them in the right polarity or anything in this kind of a setup here. Okay, so what I'll do is I'll put the black one, I'll even angle these over a little bit to show you. So for the low range, I'll put it in an angle. Hopefully it'll make connection with the metal contact inside. And then on this one, on the red, I can actually maybe put this up here, upright like that. So now we've got something that looks like so. Actually, it's just going to have to sit down there because it's just going to fall over. Alright, so there we go. There's the test leads in place. Now we have to turn the meter on. Okay, I'll just show you this briefly too. And I did show a close-up of this on the other videos. This is the range we're concerned with here. There's the word ohm, and there's a symbol for ohm. It's an omega. Looks like a horseshoe with the opening at the bottom. That's how we measure resistance, and it's the word we're looking for is ohm, or ohms. Ohms. Okay, so we'll put this back down, stabilize things a bit, and now we'll take that reading. I'll put it down to the 200 ohms, which is the lowest scale. There's 5 different scales I can use on here, and you have to click each one. Usually start low and work your way up until you get the best reading. Okay, so I'm showing decimal 7. There's just, from memory's point of view, I'll just show you another thing too. This meter, plus the wires that you have, the longer the wire and the thinner the wire, the more resistance in the reading. So you have to calibrate your meter. This one, it's either out plus the resistance that's in the wires. So what you do is you basically connect the two leads together and see what reading you get. Now, probably see a decimal 3. Okay, so now we have to subtract that from the reading we get when we take the readings from the low primary coil and the secondary coil that's within this singular coil unit. Okay, now back and make sure I get them in the right cavities again. Okay, this one's going to go here. This one's going to go on over there. And we take our reading. We get decimal 7. Now remember, it's this meter plus the wires or whatever, the calibration factor has to be added in there, or in this case subtracted. So we got decimal 7. So decimal 7 less decimal 3 leaves us decimal 4, which is just under half an ohm. Half an ohm being decimal 5, or 500, decimal 500. So that checks out on the low side. We know that the primary coil wound inside this thing is okay. So now we'll move on to the secondary coil in here, and the test places we have to make contact with. I'll make it as simple as possible. Okay, so now what I'm going to do is remove the black one, black test lead, and we're going to take this red one. It doesn't really matter, you can reverse them, you should still get the same reading. we're just going to move this up to this upper cavity here. Okay, same side, only up one space to the top of the smaller connector for that wiring harness. I'll have to tilt it back down here. I'm going to remove that T-pin from this alligator clip and test lead, and I'm going to have to reach around here and get a good connection here. Grind it in there. Make sure that there's any oxidation or whatever that you grind through it to get onto some nice shiny metal there. I've already shined this up with a little bit of sandpaper. Hopefully that'll stay put. Okay, so now you see the meter showing a 1. It's telling me that it's out of range. So now we're going to go up to the 2K mark. That was just up to 200 ohms maximum. Now we're going to go to 2K, and what K is 1,000. So if it's 2K, that's 2,000, or the limit is 2,000 ohms. So we'll click it once and see what we get. We're still getting that 1, which means we're still out of range. So we'll go up another one to the 20K, or 20,000 ohms, highest reading we can get on that range. Now this is showing us something, okay? So I'll even go up to the 200K, or 200,000 ohms. So we're starting to lose decimal points. If we go to 20 mega ohms, that's way up there, we're getting nothing. So I'll go down back to the 20K, or the 20,000 ohms maximum reading, and we're getting more decimal digits to the right of the decimal. So that is an indication to me that that's the best range to use. It's more accurate. Okay, so now here we go. On the secondary, remember you have to probe the appropriate holes in here that make contact with the metal pieces that are in there to make the connection for all this to work. So now we've got 8.03, so now we have to subtract decimal 3 out of that, so we get 7.73. Okay, so in other words, just under 8,000 ohms. The decimal will indicate how many ohms, and I'd mentioned this in another video. I like to change that decimal into a comma and then add a 0 on the end behind the 3 to the right of it. That way I get 8,000. Well, we'll use this without the subtraction just to show you, so I don't mix us both up. So if this was the true reading, taking the calibration into consideration, it would show 8,030. Or if you're thinking in terms of money, doesn't matter what currency you're using in the world that we have today, think of it as money in your pocket, or in your bank account for that matter, and that way you'll be able to understand numbers no matter what you're talking about. If you have something to relate to, I find math is much easier to understand if you think in terms of money, because just about everybody knows about money. Okay, so if that's the case, and that was a comma, we added a 0, we would have 8,030. 0 and then 30, right? So that's 8,000 and a little bit of more ohms on this range. Okay, so we know that we have to subtract the 3, so it's actually going to be 7.730, I believe, if my math thinking is correct. You can always get a calculator or a pen or pencil and a notepad and do your own math on this one. I'm too lazy today. Okay, so there you have it. That's the high reading. We're just a little under that because we have to subtract the decimal 3. So we're looking at 7,000 odd ohms there. So that checks out. I couldn't find any readings in some of the books I had for this particular style of coil. But as long as you're getting a low reading, where I showed you to probe those terminals in this specific type of coil, you should have a low reading somewhere between 0 and 0 and 1 or 0 and 2 ohms, right? And then this one, they vary. They can go anywhere from about 5,000 ohms, and they might even go 20 or 30,000 ohms. It depends on what the specific nature of the coil that you're testing is all about. So look up the specifications for your vehicle. So there should be something on the net, or if you get stuck, you can always phone up a dealer or email a dealer or somebody that knows a little bit about the specifications for the readings you need to take. That's if you're going to get this coil checked out either with your own multimeter having ohms on it, ohms reading, or you could even get somebody you know that has an ohm meter or a multimeter with ohms on it. Have them test this way. Just make sure that nothing's connected. All the wiring has to be taken off of the coil before you can make these measurements, otherwise it's going to give you a false reading. That'll add into the circuit and mess up your reading for you. So there you have it, folks. for this type of high energy coil that's not mounted in the cap. It's separate from the distributor cap. That's today's video. Hope you enjoyed it. Take care. Have yourself a nice day, and bye for now.